Hi, everyone. I'm Lynn Allen, and this is 5 Minutes into the Future. And today we'll be discussing the idea of adding a value with simulation and the way in which we'll play into the future of business, engineering, and design. Now, simulation products for designers and engineers are becoming more valuable tools than ever before. For example, according to Forrester, automotive manufacturers are making 80 to 90% of their big design decisions in the conceptual stage, when changes in simulations can be performed at a rapid pace. And users are able to complete complex analyses and continue to improve and refine products long before physical prototypes are created, which also, by the way, saves a lot of money. And we are joined today by Stephen Endersby from 3D Experience Works and Paul Miller from Forrester, who will take a deep dive on the true value of simulation and the ways it's shaping up to affect our future. So, Paul, welcome to our program once again. Can you give us a sense as to the functional value associated with virtual simulation?
Of course. Thank you, Lynn, for having me on the show. And hello, everyone. Hope this is a useful use of your time. So I guess the first thing to say, and it sort of came through in your introduction there, simulation, digital simulation, virtual simulation is not and will never be probably a complete replacement for building physical prototypes and doing physical tests. We still need the real thing. But doing a lot of this virtually and digitally speeds it up, makes it cheaper, and allows you to test for some of those unanticipated weird edge case scenarios. For example, in automotive, we reduce the number of physical models a designer has to make. And we start using synthetic data created by a computer, to allow us to test odd combinations. So for example, you've got data on how your new car design performs in real rain. You've got real data on how it performs in a real gale. You've got real data on how it performs on a real poorly maintained British road. But you don't have all three together. So you can use simulation in the computer to test driving in a gale, in the rain, on a British road. You still need that real world driving, but you're then using the simulation to augment it, to extend it, to test for the weird and the unusual things. And then just one final point, this carries through beyond the design phase into the finished product, being used in the real world to do its real job. Take a wind turbine, for example. You understand the physics. You understand how the different properties of the carbon fiber and the steel and the concrete and the plastic all work together. But let's simulate what would happen using that turbine in the howling gale we expect tonight. So in our computer simulation, ramp up the wind to see what it's going to be like tonight, to see how that turbine will perform tonight, and to allow those engineers to make a decision about whether or not they keep it running or whether they maybe feather it and turn it out of the wind to avoid damage. So these are some of the things you can do with simulation. There are plenty more, but this is 5 minutes into the future, not 5 hours. So I better stop there.
Okay. Well, okay. So that's very impressive insight into the power of simulation. Thank you so much for that. All right, Stephen. So where do you see the future of simulation heading as the natural evolution of technology takes place?
Well, then, I think if I had to describe where simulation is going in the next few years, I'd sum up in one word. It's expansion. It's actually a very interesting time for the simulation field right now. I think we're seeing the barriers to the adoption of simulation being broken down with the development of innovative new interfaces and new rapid solvers. The traditional limitations of how big a simulation you can run, how many models you can do is being broken down again, because I'm not limited by my desktop, my computer I have in my office. I now have access to cloud services. I can run it on the cloud. So I can choose how big a problem to solve and how long to make it run. And lastly, but no means leastly, we are understanding the physics more than we ever had before. I mean, the example we just had there of the wind turbine, we're not just dealing with, a single physics of flow. We're looking at the rotation of the wind turbine. We're looking at the delamination of the carbon fiber. We're looking at the interface between the plastics and the metals. We're looking at a lot of things, and we can solve more complex problems than we ever could before. And I think it's like I say, it's an expansion. If I can imagine it, I can now simulate it, and I can decide whether it's worth doing it or not, even before I've done the first prototype. I think that's one of the great powers of simulation.
Well, it certainly sounds like an exciting time to be a designer and engineer and have access to such powerful technology so you can make the best products in the world. So thank you both so much for being here. And thank you all for watching. It's been a pleasure bringing you this video, and join us next time as we venture 5 minutes into the future.